This is the Earth Science channel. Welcome back. This video is all on metamorphic rocks. These rocks are basically an integral part of the rock cycle, and I've got some beautiful pictures here. We got some slate on the left. We got some beautiful foliation and stress and force applied to rocks in this middle diagram right here. You see this beautiful layered rock side there. We got some beautiful nice rock up there on the top right. We got some marble down here in the middle, and we got some beautiful schist in the bottom left down here, and in the right we got these beautiful lines and these beautiful foliations again on the rock surface. And that's what you get with these kind of rocks. You get these beautiful patterns, and all created through certain processes under the ground, and this video is going to look at those. So this video is going to look at how metamorphic rocks fit into the rock cycle, their position, and what they kind of like work with and around in terms of processes in different parts of the rock cycle, and also look at how these rocks form and look at the agents of metamorphism. So what are metamorphic rocks? So these, basically, well, let's define the word first. So meta means to change, or basically after, like the change that has occurred after. All right? And the word morphic means to change form or shape. So if we understand the word, we can kind of figure out where this rock has come from, how it's formed, and what's it going to look like in different kind of patterns. So it really is an original rock, right? So you take any rock, put rock. Okay, this could be igneous, this could be sedimentary, or it could be another metamorphic rock, and we'll get onto why that is later on in the video. So any rock, okay, this is called the parent rock, or it's also called the protolith right here. So the protolith is the rock that is the starting point for this journey of a transformation, and this transformation of the rock into metamorphic rock is called a metamorphism. So again, what's inside, or the composition of this protolith or parent rock really will define what kind of rock you get after metamorphism, because the different types of elements and minerals that are inside that rock, once they go under metamorphism, they will have a certain change or a certain kind of characteristic when they eventually become the new type of rock, which is called metamorphic. So this happens underground. It happens underground, below the surface, so underground, at depths of around 10 to 30 kilometers. Now, it can be deeper than 30 kilometers, but the average is between 10 and 30. Now, why is it not anything more shallow or close to the surface than 10 kilometers, like 8 or 6 kilometers? It's because you need certain conditions for this to happen. Metamorphism only happens when you get a change in, or a increase or decrease in temperature, right? So this is thermal energy, and pressure. Now, pressure in most textbooks are going to be in megapascals. Okay, I like to use PSI only because I'm in the States and I can relate this to my students a lot easier with the unit of pounds, and then obviously per square inch is more like you can visualize in a three-dimensional way where the stress and the force is acting upon the rock, and you can kind of like describe it better. So I use PSI as my converted units of pressure. And when discussing pressure and temperature, you need these kind of like thresholds of which to start to begin the various levels or stages of metamorphism, the process of creating a metamorphic rock. So temperatures have to be above 200 degrees Celsius, and the pressure, this would be the lithostatic pressure. We'll get more into that on the next video, but the pressure exerted by the force of overburden and the rock above it, with obviously the addition of gravity as the main force of attraction acted upon the rocks, you have pressure of 300 megapascals. That's equivalent to around 43,500 psi, so 43,500 pounds per square inch of force pushing on the rock to create this metamorphism. And this is the start. This in detail is an isochemical process. That means that the chemistry, the elements are not really changing. They can be rearranged chemically with the elements and the level of stability at certain conditions, because these minerals and elements are going to change based on the amount of pressure and temperature that they are exposed to, and also the amount of time, which again, we're going to look at this later on. So the isochemical process is where the rock is changing, but the rock stays in a solid state, right? It does not go to liquid. It's a solid state, but in this solid state, it is with the temperature and pressure exerted on it, you can mold it and rearrange the alignment and the patterns based on the stability to create your new metamorphic rock. And this would create what's called a recrystallization process within the rock going through metamorphism, which means that the minerals will be aligned or rearranged, and that would change the form or the shape, and that could also dictate the texture, the appearance and the coarseness of the surface of that rock can change. So the factors, as I mentioned before, the factors affecting metamorphism. So the different factors that are controlling the formation of these rocks are called agents, and the agents of metamorphism. So we looked at agents in terms of erosional, and this basically means just the different ways or types or methods that occur naturally in nature which allow this process to happen, to continue to occur. So the three, you got temperature, you got pressure, and you've got the addition of fluids. And these three combined, working together underground at depths between 10 to 30 kilometers, or even in some cases further down, are going to be what creates this metamorphism and creates the metamorphic rock at the end. So temperature. So where does this come from? So you've got the natural decay within the Earth's interior, which creates heat. You also have a big deal from pressure. So the increase in pressure will increase the temperature as well. So this based on what's called the geothermal gradient, which is on average around 30 degrees Celsius for every kilometer of distance you go underground, so increase in depth. So if you're going to go 1 kilometer down, you're going to increase temperature by 30 degrees Celsius. But going 10 kilometers down, on average, based on density and different materials and properties, you're going to, on average, increase temperature to around 300 degrees. Now, for metamorphic rocks to start to metamorphosize or change, you need temperature above 200 degrees Celsius. Anything below that is called diagenesis, which is in relation to the sedimentary rock process with compaction, sedimentation, lithification. All right, so this is part of a cycle of diagenesis up to metamorphism, and before we get to melting, because if we get too hot at a certain depth, or even at a lower depth, a shallower depth, but if you get to a temperature, around 650 degrees Celsius up to 800 degrees Celsius, you're going to start to get partial melting, whereby some minerals inside this rock are going to start to melt. For example, olivine, is the first to crystallize under the Bowen's reaction series, but however, it is the first to also melt. Whereas quartz is the last to melt. Quartz has a melting point of around 1700 degrees Celsius. So each mineral has their melting point. So when you start to get certain temperature around 650 to 800 degrees Celsius and up to 1700, you're going to have more and more melting of that rock. So again, metamorphic rocks do not form when the rock is melting. It is just a solid material process which is changing the rock. It has nothing to do with melting. And as I mentioned before, we can get temperature from pressure and lithostatic pressure, which is basically the rock here. You have the pressure coming from all sides, really, okay? But also you have pressure that comes from certain directions, and in terms of like compressional stress, all right, which is, here's my rock, there's my compression right there. You're going to increase the temperature based on obviously the depth, but also the pressure and the different types of stress that create that force on the area, which is pressure. So I mentioned before, pressure can come in lithostatic, can also come in differential, which means that there's a range or variation in the direction of stress applied to that rock, okay? And this pressure is, with the addition of temperature and the addition of fluids, is able to mold and realign and reorganize the mineral patterns and the structure, which would then alter or change the appearance and the texture, and even change the whole rock completely and be a completely whole different rock in terms of its appearance. And finally, the fluids. When you are closer or in shallow depths, or we're in certain conditions like subduction, or let's say hydrothermal vents, obviously by the name, or we're looking at any kind of like divergent plate boundary or mid-ocean ridge, or in terms of any kind of magma presence, because magma, you have dissolved gases and fluids, any kind of magma present which is to do with contact, metamorphism, which we'll get into in a different video. But the fluids are a major component that obviously can fluctuate in composition, and also the amount of fluid within the environment that can react. Now, this reaction happens inside the rock during metamorphism, and generally it's going to increase the rate of chemical change. The rate of chemical change within the metamorphic or metamorphism process, and will allow ions and different elements in solution to react with the rock to form new minerals. And you can either have an addition or subtraction based on the chemical reactions with the fluids within that new rock, which would change and alter the appearance and texture and composition of that new metamorphic rock. You have the difference between a wet environment versus obviously a dry environment, and that would change obviously the rocks that you get as a result of metamorphism. And there are different sources. There are different sources of these fluids. Now, I mentioned different environments, but the main one is water can come from pores within the hydrous minerals. You can have the presence of magma and different volatiles. And I did a video on what magma is, so please check that out. And also the reaction with the country rock. Now, country rock is the rock that surrounds any kind of magma intrusion at shallower depths in the crust or lithosphere, and how that magma is going to react with both pressure and thermal energy to create what's called contact metamorphism. So that magma volatiles will be in the magma as it reacts with the surrounding rock, which is called country rock. Then the last source really is dehydration, which is kind of like the removal of liquid or material through precipitation. This can happen in some karst environments with the presence of different minerals left behind with various hydroxyl groups, okay, and elements, and how this karst environment can be then buried or through burial and go through the stages of diagenesis into metamorphism, and how those fluid minerals and elements are already in the rock present for them to go through metamorphism. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel and don't forget to subscribe. Thank you again.